My name is Graham Davison, and welcome to my talk, Third Time's a Charm, Introducing and Evolving a Chef Infra Implementation. Just kind of go over who I am, then the stories of several different implementations that we tried out. First two are implementations I tried out at a previous employer, and the third one is when we were planning while I was there, but then I left for a different employer before implementing it, but then I've implemented it on my own. All right, I'm currently a senior software engineer at HashiCorp on the Terraform AWS provider team. So being in Canada, I can't call myself an engineer, so pretend you didn't hear that. That is officially my job title. I previously worked at a company called Pay by Phone, which lets you pay basically for parking using an app. A lot of over 100 cities across North America, Europe, and the UK. If you're in Seattle, Vancouver, San Francisco, and a bunch of other, London, Paris, a lot of places like that, you can use their app. Started out as a back-end developer at the company, did that for about a year or so, and then was the founding member of an infrastructure automation team that we set up to move away from being a point and click systems administration and basically commodity data center operations. And then for the last 2 years on the team, I was actually managing the team. And just to be clear, I'm speaking just for myself, not speaking for either HashiCorp or Pay by Phone. So we started in 2015 with really trying to find our way with the Chef Infra. Once we decided to go that route, then we had kind of the two implementations that we ended up using. Both started in 2016. First off, gaining some stability in our on-premise data center and getting some tooling around that, and then also making some steps into AWS and the cloud. And then 2017, 2019 was feeling the growing pain from some of the decisions that we had made early on and ways to address them. So in the beginning, before we created the infrastructure automation team, we had actually a fairly small data center. We only had a handful of servers that were running. They were long-lived and well-known. I've made up some names here, but it's a similar naming pattern to that. The naming pattern essentially identified where an individual server was located. Everything was encoded within the name, whether it was a production server, which rack its VMware server was hosted in, and a few other things like that. We had started out with monolithic .NET applications running our Windows server. And any deployments, any updates were a high-touch manual process. Took hours to complete for if we brought up any new servers. So there was some PowerShell scripts that were run as part of that hours-long configuration stage. Everything was running on vSphere and VMware, and we used a tool called Octopus Deploy to deploy the actual applications onto the servers once they were set up. And we were a payment card industry data security standard compliant environment. Basically, if you want to process credit cards, you have to comply to these standards. And there are yearly audits and a whole bunch of processes around that to enable you to keep processing credit cards. So then we decided to add an automation team. We really wanted to increase our server deployment speed, since that was a bottleneck to the development teams. Anytime something new had to be created, there was a hours-long process once the job was actually started, but sometimes it would go weeks before the work was actually started. We started out with a team of 3 people on this infrastructure automation team, and we all had experience in the different the 3 main configuration management tools at the time. One with Ansible, one with Puppet, and then I had pre-existing experience with Chef Infra. I'd actually learned it on a personal project where I heard about a tool called Vagrant, which would let you create local VMs for testing. It was at that time run by a student out of the University of Washington. And in its documentation, it suggested using this, this interesting tool called Chef Infra, or just Chef at the time. So I looked into that and kind of carried on with that and used those skills, you know, through, I guess, the rest of my career. And that student, Mitchell Hashimoto, went on to found HashiCorp, actually. So we ended up deciding on Chef Infra. We spent some time evaluating all the tools. There were some discussions, some of them heated, some of them we actually were having good communication. We used Windows workstations for all our developers at the time, and so that ruled out Ansible. I'm not sure if it really runs well on Windows now. It definitely didn't at the time. You could configure a machine, a Windows machine with Ansible, but not run it. Then one of my colleagues wrote a series of blog posts on his blog. I've got the link there. It's Van Kluver Tech, and then all his configuration management articles. They're 5 years old, but he did some really in-depth research and kind of an interesting look at where all those tools were at that time 5 years ago. And from his research, he was convinced that Chef Infra was the best tool to go with at that time. And he actually goes into some depth in some of his articles on his blog. So our first steps getting going with Chef Infra were a little rough. We were learning as we went, and really had no cohesive plan or design. We all kind of scrambled off in different directions, doing learning as we went. So we had one person was working on our Greenfield Linux infrastructure for new servers, so we're spinning up, and the style he went for implementing things led to a lot of environment sprawl. He used a lot of environments for configuring things on the servers rather than some of the other facilities that were available in Chef Infra, like roles or just setting values on the nodes themselves. In contrast, when we were setting up the Windows server infrastructure with basically backfilling a lot of the configuration on our existing Windows servers, we used a few high-level environments and then used roles and the actual node configurations for when we created those. But launching those VMs was still a manual process, but using Chef Infra did shave a lot of time off all the deployment time. And then we decided on a tool called Chef Vault for managing the secrets, and that ended up causing us some problems down the road. Well, I guess not problems, but added some complications down the road. Essentially, for every node you have, it will re-encrypt the secrets with a key for that node. So we started out in our data center. That was our first place we implanted things. We had some change on the team. Someone left and a new person joined. And all the development teams had made a decision to move away from our monolithic application architecture and instead move to, up to that point, the mobile app was just showing a mobile web page in a web view, essentially. We decided to go with native applications, and they would talk to APIs on our backend. So it was a major architectural change. And one of the consequences of that was we would have single applications or single API applications per server. So we're going to be spinning up a lot more servers. So on the left here, we have our old architecture, which had the monolithic website and some backend services. And on the right is a new architecture, just some sample API services there, but multiple servers for each of those APIs. And by the time I left Pay by Phone, we had one legacy service that didn't scale very well, and it ended up actually being deployed on over a dozen servers, just because of how much processing it needed to do. So the team member who joined during this time created a whole bunch of new tooling for us, basically through plugins to Knife. I hadn't realized you could do that, but she did a bunch of research and found their Knife itself is extensible, which makes sense because a lot of the additional tooling that you can use through Knife is available as downloadable plugins. And these tools that she created helped us gain a lot of efficiency in how we worked with Chef Infra, and that really helped as we expanded the number of servers we had. So traditionally, if you're creating a new node on the Chef Infra server, you'd call Knife node from file, and then the JSON file that describes the node. And to edit it, there's a similar command, Knife edit. And then if you're wanting to make changes to the run list, the list of cookbooks or roles that are on the node, you can use run list add, run list remove, or run list set. And typically you would have to do that work node by node. And the only source of the data is on the Chef Infra server. There isn't, so if you needed to make those changes, you would have to call Knife edit, and that would bring up your editor. You make the changes and save it, and then it would update the node information on the server. So the new node tools helped us make edits on sets of nodes. And source of truth was still the Chef server, but we had node configuration files for all the nodes that we could put into source control. So it really helped us when we wanted to make changes across the whole fleet of servers or add servers, that kind of thing. And one concept she introduced was the idea of node templates. If you had a whole set of similar servers. And the way this worked was kind of interesting. Typically, the nodes are represented using a JSON file, or if not a file, when it's downloaded from the Chef server using Knife edit, it will be in a JSON format. But it can also be described using a Ruby syntax. And I know I'd seen documentation on it a number of years ago. I can't for the life of me find it anymore. So I don't know if that's been deprecated or just is now obfuscated, since it is planned to be deprecated maybe. But using Ruby as the language allowed for us to do some scripting and make things a little more programmy. And then we also leveraged the Ruby templating language, ERB, to create these node templates. So I have an example here of what one of these templates would look like. Using the same naming pattern as had in the images before. So ABC web, and then it's got a whole bunch of numbers in there, and then it's got some values that get filled in. Down below, you'll see a lot of the similar keys that you get in the JSON JSON format. A node name, and in this case, we're templating it to use fill in ID there. This one's going into our prod CDE environment. We're setting some attributes on the node itself, and then adding some recipes into its run list. Then this would get called with the tooling, and it would actually create 9 servers there based on this description. The file name itself encodes all the servers that will get created. So using these templates, we could create and edit nodes in bulk. There was a new command added, Knife nodes from template, and that would, using that template, would then create all the node records that we wanted on the Chef server, Chef Infra server. And then another command, Knife nodes update from template, would update all the node records. But first it would show a diff in case something had been changed out of band, or someone else had been running some commands on the nodes as well. And both these commands re-encrypted any of the Chef Vault secrets as we went through. And the node files, the template files themselves could actually, you could actually list which of the Chef Vault secret items you wanted to have associated with that node. So if we use that example file from before with that naming of the template there, anything with dashes in there would create all the numbers between that, and then commas would create individual items. So we're creating web 031 through 38, and then also 41. I guess in this case, someone else on some other project has created 39 and 40. All right, and we also wanted to launch these nodes onto the VMware servers. There's already an existing plugin for Knife that lets you spin up servers, Knife vSphere. A whole lot of command parameters for it. Some of them have to do with the node itself. Some of them have to do with all the parameters that you need to set when actually creating a virtual machine that will be spun up on VMware. And the node has to be node record has to have been created on the server beforehand. So with the enhanced tool that my colleague created, we could use those template files again. So I believe the naming was Knife VMware from template, and it would go through all the templates and create new VMs. We'll first create the node records and then create the VMs using that information. And we can now launch a whole bunch of servers in just one command. And that could let us spin up a fleet of several identical servers. I forget how long it took. It wasn't actually that long. If we had done it manually, it would have been work of several days. I think it would be a couple hours at this point using the tooling instead. We also wrote a large number of internal cookbooks to configure our machines. We used a lot of the community cookbooks. Many of our cookbooks were wrappers around the community cookbooks, or tied things together, or if we had, say for our logging cookbook, we had one logging implementation for our Windows servers, one logging implementation for Linux servers, and we had a common logging cookbook that would tie those together and get us similar configurations or similar outcomes from the logging setups on both types of machines. And we did all the development and testing on our workstations using Test Kitchen. And we knew we needed to get a pipeline in at some point, but we thought we'd put that off until later. All right, so we started with a handful of servers in production and a similar amount in our development and testing environments. By the end of this period, we had over 80 servers in our production environment itself, and 6 different development environments for our development teams. And the development environments each had 6 servers in them. And then we had an integration testing environment, which was on the order of 50 or 60 nodes. So that's quite an increase in size, and we were able to use all this tooling to keep it running. And our next step is moving into the cloud. We have one data center, which was located here in Vancouver, Canada. Of course, we're waiting for our big earthquake to happen at some point. Not great for hosting a data center necessarily. We had a cold standby in the UK at one point, but the switchover had never been tested properly, and it eventually got out of sync with what we had deployed in our Vancouver data center. And just like with backups, if you have a standby site that you've never tested, you don't really have one. And hosting out of Vancouver, and only Vancouver, gave us a really high latency for our users in Europe and the UK. If we were using the application locally, we'd have responses back very quickly. But any back and forth was sometimes on the order of seconds for our overseas users. And all the nodes in our data center were static. There was no no scaling. There was no easy way also to add capacity without planning it out, without you know, having to run the tools. And obviously, the tools made it a lot faster, but it was still involved human intervention for that. And then we had people, and we're retaining a skill set of running cabling, racking servers, and that's commoditized. It doesn't really let us you know, focus on the value that we add. It's having people who are having skill sets that are you know, not adding. I want to phrase this. It's needed skills, but it's not something that drives us forward for new capabilities. So in late 2015, we decided to make a move to AWS to not have to manage our own data centers anymore. So in order to kind of cut down a lot of complexity, we essentially decided to replicate a large part of how we're doing things in our own data center in AWS. So not going with any real cloud native technologies or anything like that. The benefits of this were that it was a known architecture. You know, we knew how to manage it. The development teams wouldn't really have to change. In theory, they wouldn't really notice anything was different, except that the servers would not be local. They'd be, you know, different IP address ranges, things like that. But the platform we were providing for them wouldn't be any different from what they were used to. And we could pick up some useful features, things like auto scaling and a bunch of easier automation for what we wanted to do. Now, things like auto scaling and dynamic environments in general complicate Chef Infra because nodes can come and go. Either they you know, we terminate nodes and launch new nodes regularly for updates, or if we need to increase or shrink our traffic capacity. And those nodes need to be removed from the Chef Infra server once they terminate. Otherwise, they just kind of, you know, the records kind of get intermingled with what's active and what's not. So it needs to be cleaned up. And in addition, because Chef Vault encrypts each of the secrets for each node, it doesn't really scale well with dynamic nodes. We would have to find a way to essentially tell the Chef server to re-encrypt when something gets created, and then tell everything it's going away later on. This was somewhat easier to do with the nodes themselves, node records themselves, but with Chef Vault, it seemed like a bigger problem. So to address that in AWS, we started out with storing secrets in encrypted S3 buckets. Then later on, we started using the Systems Manager parameter store values. Those can be encrypted. Later on, AWS introduced Secrets Manager. We never really used that. And ideally, our long-term strategy would have been to use something like HashiCorp Vault because it allows the ephemeral credentials and a bunch of very, very useful things like that. But there's one problem. The three of us on the team at the time were not communicating well. It was kind of a breakdown in the relationships, and we're all, you know, smart people. We had our own ideas of how things should be, our own vision, and we never really took the time when the team was starting up to kind of get everyone on the same page. And we all kind of had settled into addressing different areas of our implementation. But we didn't get a shared design, a shared understanding of what that implementation was supposed to be like, other than a very high level. We're going to move everything to AWS. So And then we often didn't think of how the decisions we made for implementation would affect the other people on the team and what they were trying to implement. And we also focused too much on the implementation, just getting something done, something running, rather than having that that holistic idea. And I think we all kind of, assumed, we all agreed, and it was all, of course we'll do it this way. And the worst cases, sometimes a whole bunch of design was done independently, and then implementation was done on that design. And then after a bunch of that work was done, it was presented to the rest of the team. And then if we had questions or there were disagreements with how something was done, unfortunately feelings were hurt. And our manager at the time was very hands-off, and really we were hands-off is a very, he's pretty much AWOL from us. I think he had expanded a bunch of his responsibilities, and he just kind of let us do our thing. And so because relationships had broken down, we weren't kind of doing that proper work of opening communication ourselves. Manager at that point should have probably stepped in and, told us to smarten up, but I'm not sure what was happening at that point. That's definitely on all three of us. So as I mentioned before, we're trying to replicate our on-premise design. And what we had in our on-premise was a couple of standard images that one for the web API front end and one for the service backend. And those would basically be customized, for our payment service and our member service and our parking service, all these different services. But they provided a common platform, and then the applications would be deployed on them using Octopus. So we had decided to essentially do the same thing in AWS. And we would create one image that would be shared across all the accounts. And then we would customize them across different environments at launch time. And one of the reasons we did this was we were prematurely optimizing for cost. We were like, oh, storage is expensive. Well, really, storage in Amazon is among the cheapest things they have. So that was a real mistake there. We probably should have customized things quite a bit more for the different environments. So we need to create the Amazon machine images. And a great tool for doing this is Packer. Yet another HashiCorp tool. And it basically is a tool to create a whole bunch of different kinds of images, whether it's VirtualBox, Amazon, Azure, VMware. And you can use one common description to then create these multiple types of images. We just used it for creating the AMIs in Amazon, or AMIs, depending, whichever you prefer, whatever pronunciation you prefer. And Packer has a Chef Infra provisioner. And so we could leverage all the investment we had made in creating our own cookbooks and adapting community cookbooks. So it was a great tool for us. So once we had these standard images created and deployed and tested a little bit, we needed to configure the machines at launch based on what environment they were deployed in. Chef Infra would have been a great way to do this. We could just finish off any configuration, could pick up any updates that had been made, since the image was created. But this is one of the places where our team breakdown really impacted us the most. The Chef Infra server was on our on-premise data center, and looking back, we probably could have spun up another Chef Infra server in our AWS environment. I think we didn't realize at the time you could have multiple infra servers, and then so basically the nodes in AWS would need to communicate back to the Chef Infra server in our on-premise environment. Another reason we adding another Chef Infra server would have been complicated was that we didn't have a great deployment pipeline for the cookbooks. They were all developed and deployed from our workstations. If we had had a proper pipeline for that, we would have been able to deploy to multiple infra servers instead of just a single one. So to communicate back to the Chef server in our on-premise environment, we would have needed a VPN connection between the two. And the person working on AWS networking didn't want to allow that. And in part, his vision was more around immutable instances. I think he had a very forward-looking and more modern infrastructure approach than what we had been directed to and decided on when we were starting this out. A next generation after we had moved everything into AWS, that probably would have made sense, having more immutable stuff. But so we had a communication breakdown around that. And so there were 3 of us on the team, and the one person holding out, the other 2 of us weren't really able to communicate and weren't able to change his mind. Though looking back, I'm not sure how much, if I'm honest about it, how much effort we put into it. Really, we should have had everyone sit back down and go back to basics, make sure we're all on the same page, talking about the same thing, had the same end goals in mind. But things were kind of in a bad state in our team. And unfortunately, if we had sat down and had that talk, would have found out some basic misunderstandings that he had, and he really hadn't understood what Octopus, our deployment tool, was and how it worked. He thought it was more of a job scheduler, some sort of Habitat or Nomad type of thing, rather than just deploying .NET packages onto a server and launching them. And I found that out later on after several months of implementation of a workaround for that. So what I did was spend several months creating some tooling. We called it Chef Bootstrap. I'm not trying to step on any of Chef's trademarks here, though. And this basically let us work around not having that access. So we started out with they're mostly Windows servers. So it was a PowerShell script that would be called to start up when an instance started up, and it would call an arbitrary set of scripts that were stored in a specific directory. Many cloud platforms provide a user data information that instances can read when they're starting up or when they're doing management tasks. And scripts and parameters can be set in there. So we would store parameters that would be used to configure the machines at runtime there. And then the scripts would be called to configure the machine, and that would finish them off. So for every cookbook that we used for both on-premise and in AWS, we had to have 2 code paths, one that was used on-premise and one that was used in the Packer builder, and that would set those scripts in that directory. And then this Bootstrap also used configuration files that could be built using templates. We found a utility that essentially wrapped the Go templating function calls in a command line utility. And so we had all of our configuration files that were used using Bootstrap were implemented in the Go templating language rather than ERB, as all the Chef templates are. And then I did the whole thing over in Bash for our Linux systems. And it was really a cool solution. I was, spent a lot of work, did a lot of researching, Cool solution to a problem we never should have had. And yeah, a little bit of talking can solve a lot of problems. But Darth Vader once said some wise words. Don't be too proud of this technological terror you've constructed. Bootstrap was a maintenance nightmare. We had 2 or 3 languages to write configuration code. Ruby for Chef Infra itself, and then PowerShell and or Bash. We had 2 or 3 methods of specifying parameters. Either in the node, or the Chef Infra attributes, or else in other code, such as the Terraform that we use to spin up the environments. And we had more code paths to test. In the simple case of a cookbook, you just test a few of your paths, but then we also needed to, or should have, I guess, in this case, should have tested the Bash and the PowerShell a lot more than we actually did. And that would have involved a different testing harnesses as well. But all these things that Bootstrap did, it's exactly what Chef Infra is designed to do and does exceptionally well. So I'd essentially spent time re-implementing sections of Chef Infra twice. And then to make things even better, we eventually did have a VPN anyways, because we needed it for Octopus to deploy all of our applications. We ended up deploying a few static servers in AWS. And we just deployed those and configured them directly using Chef Infra. And so even though they were in AWS, they were using the on-premise cookbook configurations instead of the AWS cookbook configurations. We had some naming problems where it wasn't clear that the naming wasn't good around, I think it said AWS in the name itself as opposed to, Packer Builder or some other better name. Okay. And then, as I mentioned before, running Chef Infra with dynamic environments, you have the nodes. They register themselves with Chef Infra when they start up and get configured in the first place, but they don't clean up after themselves when they go away. So we did some work here to essentially tie into an event system that AWS provides. In this case, we're looking at the lifecycle events from the EC2, the compute nodes in AWS. My diagram isn't entirely accurate here. It says auto-scaling groups, but it actually will work for both auto-scaling groups and instances that aren't in an auto-scaling group. But in this case, we're looking for node terminated events, and that would be sent to CloudWatch events, and that would get picked up by the Lambda. Lambda would call home to our Chef Infra server back in our corporate data center, and using the server APIs, it would clean up the node and then also the client record. But things were working, and it went on this way for a while. We had these two complementary yet conflicting ways of dealing with our Chef Infra, but it was painful. We had, because we had these multiple ways of multiple code paths, we sometimes the Ruby code or the scripting code for the Packer Builder method, they got out of sync. So we had weird problems. We didn't have any real comprehensive testing. We didn't have a way of testing what a whole configuration would look like. We were doing a lot of our cookbooks kind of piecemeal. And it was a really good thing we never got around to automating the chef client runs in our production environment. We did have it in some of our testing environments, and it ended up working fairly well, but sometimes it would make the jump to hyperspace if we had, if there were problems, conflicts between the cookbooks and all that. So now we have a configuration or an implementation that I think would have addressed a lot of those problems we had. We had decided to push a number of issues off to later, but later was very quickly becoming now. Some of the issues we had were we were stuck on an old version of Chef Client because some of our upstream community cookbooks hadn't been updated in a while. I believe we were forced to use version 12, whereas the current version was first 13, then 14, and then 15 finally. And I know that version 16 is either been released or about to be released. So we were just stuck far behind, and it was causing us some frustration. We also had versioning conflicts between some of our in-house cookbooks. One of our core cookbooks, the logging one, we actually had removed the Bootstrap part of it because we thought, oh, we'll be going straight to proper chef implementation very soon. And of course, that never really happened. And we wanted to add new features onto this logging cookbook. And we had to essentially put all that Bootstrap code back in there. And it was, that was not a good feeling. And we didn't really have a good way to test, as I mentioned, a full system configuration. To make sure that all the different pieces with logging and application configuration and the various different services are running on the machines, that they all worked together and didn't have any weird conflicts. And then we also were a PCI DSS environment, so we needed compliance scans and their yearly audits and all that. And we had tooling in our existing on-premise data center, which is where all of our actually PCI environment was located. And that wouldn't handle any dynamic environments. And if we were moving everything into AWS, we would obviously have to handle dynamic environments. So we needed a tool that would handle that. So we started to design a future setup that we wanted to use that would meet a lot of these, that would fix a lot of the problems we had and meet a lot of these new design features we wanted. So we decided to use Chef Automate to collect Chef InSpec compliance data. We had a lot of experience using InSpec because all of our cookbook testing was done using InSpec. So it was very useful to have this, use the same tooling, same languages to get compliance information as well. And there are a lot of community InSpec profiles that can be used to verify compliance, plus the Chef Automate also includes a number of proprietary profiles that match up with a lot of the standards that the auditors want to see. We decided to modernize our Chef Infra specifications to use Policyfiles rather than Berksile for version management and using chef environments and roles. And then we also wanted something that would use AWS services where appropriate. There's a good article on the Chef blog called Policyfiles, a Chef Best Practice, that describes a lot of the benefits of using Policyfiles. Call out a few of them here that really stood out for us. They simplify a lot of the cookbook versioning. You can actually lock down exactly the versions, so you won't have a version drift or anything once you've created your Policyfile lock. And they consolidate a lot of the ways of specifying configuration from environments and roles into one place. And it took me a while to kind of get on the bandwagon for Policyfiles, but now I wouldn't use it any other way. It just takes away a lot of the complications and makes things a lot smoother. Right, so it was while we were designing this new approach that I accepted the position. I'm at HashiCorp now and left pay by phone. So what I'm going to present now hasn't actually been used in a production environment, but it implements some of the ideas I had before leaving, and I have tested it myself. So changing from Berksile to Policyfiles, really there's no change in how you're working with them. The commands are essentially the same. You're going from for uploading cookbooks using a Berks install and Berks upload, or Chef install and Chef push does essentially the same thing. And then modifying nodes with Policyfiles, you're just setting the policy, whereas in the non-Policyfile version, you can set the environments, you can set the run lists, a lot more pieces to move around. And then when we are using Chef InSpec for compliance scans, there are a few more decisions to make. Since the plan was to deploy Chef Automate, made a lot of sense to host the InSpec profiles in Automate, though there are a bunch of other sources you could use. You can download them directly from a Git repo. You can run them locally. You can download them from the Chef supermarket, a number of different sources. And then you need to choose how you want to run these compliance scans. One way is using the audit cookbook, and that can allow you to upload a compliance scan after each Chef client run, and it can either go directly to Automate, or it can go through the server, the Chef server, and proxy it. The design we're looking at was to do semi-immutable infrastructure, run Chef once at startup, and then any changes after that, we would actually tear down the machines and spin up new ones with new configuration. So this wouldn't really have worked for us. Chef Automate can run scan jobs itself. It can initiate them. This requires Automate to call out to the nodes, and for things in the in a PCI DSS compliant environment, that wouldn't have worked unless we also brought Automate into the compliance scope itself, which would have been not ideal. AWS Systems Manager has a compliance set of tools that can run InSpec profiles now, but that doesn't interoperate with Chef Automate at all. You can't, it doesn't directly use profiles from Automate, nor does it upload the results back to Automate. It's entirely within the compliance tool set itself. Another option would be to use native task schedulers on the machines, such as cron on Linux, or to schedule tasks on Windows. This, however, would require configuring the scheduled tasks in something like Chef Infra, and then you wouldn't be able to change what was being scanned for, wouldn't be able to change how it worked or what the schedule was without reconfiguring the node, which is something we wanted to avoid, or I guess tearing down and spinning it back up. So another thing that AWS Systems Manager provides is a way to define sets of tasks. They call them command documents. And you can link those to sets of machines. And then using the Systems Manager State Manager, you can execute those documents on a schedule from lowest of every 30 minutes to a much higher period. And one advantage of many of the Systems Manager services that includes Systems Manager State Manager is you can use it with on-premise machines as well as machines that are in AWS. So to test this, I put together a setup in AWS with a Chef Infra server, Chef Automate, and then some nodes configured with a simple Nginx site without any hardening. So this would fail the hardening profiles. I created an AWS Systems Manager command document that's set to run every 30 minutes. And I don't have the code posted yet on GitHub, but I'll need to clean it up, and then I'll post on GitHub so people can take a look at it and try it out. And this is just some of the stats from when I was running it. Here you can see had 6 failures on a couple nights ago when I was running a bunch of the nodes, and then shut them down, so it went back to 0 failures. All right, so along this 5-year journey, learned a few things that really kind of stood out. Even if we're working in a technical field, it's usually not a technical problem. Communication is key, process is key, and then we also do some technical things. But unless you're working at a really high level or some very deep stuff, your problems most likely aren't the technical ones. Excuse me. Another excuse me again. Another key thing is to really finish your project. We ran into this a number of times, and it was a problem at Pay by Phone, and a personal thing of mine is to get projects to a certain point where they're working. We had all of our cookbook testing working from our local machines. We had our Packer configurations working from our local machines. We never took those maturity steps up and built them into some kind of continuous integration build pipeline where we could automate it a lot better. Chef Infra has a great community. I mentioned we leveraged a lot of the community cookbooks, and there is a group called the Sous Chefs who do amazing work, working on a lot of really core cookbooks that the community uses. They also will adopt cookbooks that have been abandoned that really add value to the community. And then also in general, the community things like the community Slack and awesome things like ChefConf when we have ChefConf offline. It's a great community. And then if you're doing Chef Infra, use Policyfiles. It'll make a huge change in how you're working, or at least I found it did. And some contact information there. So that kind of concludes what I'm presenting. I noticed we had some questions pop up.
Yeah, did you find them? The first one is, did your server count largely stay the same during your transition to AWS, or did you expand it?
Oh, there we go. The transition was kind of an ongoing thing. We hadn't completed it, even though we're spending multiple years on it. So yes, it did, because we essentially were increasing in traffic. From what I hear now, unfortunately, parking traffic has pretty much dried up in our current situation, but the traffic was increasing. New markets were expanding in that. So we're adding services on premise because a number of our services that due to historical reasons or just not enough progress in breaking up the monolith were in scope for PCI, so they had to stay in the on-premise data center, whereas they could, in theory, have been moved into AWS. But then our central database was also in the on-premise data center, and most of the applications still talk to that. So that kind of restricted us with moving a lot of things into AWS. And get back to the actual question asked, did the server count increase? Yes, we were, but not entirely just because of AWS, but we're also adding new services. So we ended up with, we had a couple services that moved. So we dropped those servers from our on-premise environment, but then we had those services were deployed into AWS, and then we were able to, in some cases, reduce the server count just based on different instance sizes. But then also, we're adding new services and not always retiring old services. So just a lot more servers were being added than the few we were able to decommission. So hopefully that answers the question.
Cool. Another one here, any consideration at the time of Chef Client in local mode instead of user data, PS, and Bash?
Embarrassingly, no. Yeah, that actually would have been a great idea. I wish I thought of it.
I'm not sure how much local mode was really popular or announced at that point. Like it was always kind of there, but like not always as full featured as a lot.
Well, I mean, at the time before local mode came out, there was Chef Solo as well. So I think, yeah, that would have probably worked well. Though I'm trying to think of how it would implement that, just because it would have need to deploy all the cookbooks again, or else we could have had things where services would get overwritten and we'd have to replicate the all the node configurations.
Yeah,
it'd be doable, but
you lose all the logistics that the server gives you.
Yeah. And I think for another plug for Policyfiles, one interesting thing you can do is you can take your policy file and export all the cookbooks required into either a directory locally or into a zip archive, and you can then put that somewhere. I actually used that when I was deploying the Chef Infra server that I used for my testing, and then also the for the I didn't for the web nodes, but I used some community cookbooks that configure a chef server and package those up into a zip archive or a gzip archive, and then put that in an S3 bucket. So then when the Chef's Infra server node starts up, it uses Cloud-init in its user data. And so the first thing it does is downloads the gzip file and unpacks it, and then runs Chef Client in a local mode against it. And then that deploys the Chef server and everything. And then the only things I needed to do manually after that were we're tying it in with Chef Automate. And if I had set up Chef Automate first, I probably could have automated a lot of those pieces. So yeah, it's a really cool feature that you can use. And I think was it effortless infrastructure? I believe that uses a similar packaging mode. It essentially cuts out the chef server aspect of things. So you're just deploying nodes with a prepackaged setup, and then I guess it ties in with Automate directly.
Yeah, absolutely. One more here. This is interesting. So this person's currently on Chef 12, so a little behind. Utilizing local mode, managing about 6,000 servers on and AWS, so lots of stuff there. They're looking to upgrade to 16, transition to Policyfiles. What would you say is the biggest thing to keep an eye out during the Policyfile transition? Oh, there's so much in there. We've been talking about 12 in the community Slack the last couple of weeks. There's a lot of folks still working in 12, and like step one's like get to the last release of 12, And then the hard part is 12 to 13, because that's where there was a
Okay.
bunch of deprecations and stuff. But like,
Yeah, I remember that.
as far as like the migration to policy files, I don't have a clear picture of what that looks like yet.
I think policy files, probably the easiest part of that. It's, you know, you essentially take what you have on your node configuration and look at the run list, and then essentially create that run list in, recreate it in the policy file. And you can kind of have that as a standalone policy file. It doesn't have to be in, I guess for the ones you're actually using directly on a machine, you're not going to have that in a cookbook, for instance. But essentially, you'd recreate your run list, and I guess you'd also have to look at what's in your environments and all that. So depending how much of or how many environments and roles you have, that could complicate some things.
Mm-hmm.
But so essentially, you'd have to have a policy file per combination of roles and environments.
Yeah, especially to keep in mind for the policy group doesn't hold data, so like you want to make sure we bring everything that had been like in an environment. If there had been like environment level variables, bring that stuff out so it can come forward into other policy file stuff. So,
yeah.
Right.
Yeah, and one thing we found with our environments, we had a lot of our configuration data in there. I missed adding some slides on that. We had some cool tooling around the environments as well. But yeah, we had massive amounts of environment configuration. And then policy files, if you're going that route, you can essentially inherit from other policy files. So you could, for say a specific type of server, you could have the one root policy file that sets the the run lists and any shared configuration across all of them, and then have say a production web server policy file that just adds attributes to it, and then a QA web server policy file that adds the different parameters for that. I think that would probably be a good approach. Yeah, it really depends on how many different bits there are between environments and roles and configurations directly on the nodes themselves, which you can still do with policy files.
Yeah, indeed. Awesome. I had one question. Like when you were like early on, you were talking about like how you were getting your nodes created, which with actual templates and that stuff. Like you guys weren't bootstrapping them. You were just creating. Was that because there were windows? Like that whole story was fascinating to me.
Let's see, how do we do it? I think the tools underneath called Bootstrap. Called like the Chef Bootstrap or Chef Windows Bootstrap. But it did it all in one step. Either, I guess the node update and node create, they didn't. They just manipulated the node records on the Chef server themselves. But the VMware tooling did the whole. Register the node record, spin up the VM on VMware, and there is I think I put it in that little extract of the parameters. Yeah, there is a Bootstrap true, which it does the whole Bootstrap process. And then, one thing I left out was you can also do the Bootstrap Chef Vault in there, and that will do all the Chef Vault encryption and that for you.
Cool.
Yeah, I think the knife vSphere call inside the custom tooling had probably 20 or so parameters to it. It's it's quite the beast if you look up the documentation on knife vSphere VM clone.
All right. Does anybody have anything else? Looks like we're good to go. Graham, thank you so much for joining and sharing with us today.
Great, thank you.